So I've got AI agents booking my meetings, drafting complex project reports, analyzing, huge data sets. And this is happening while I'm focused elsewhere. Maybe even, yeah, while I'm sleeping. This isn't some far off future. It's actually happening now in production systems.
It really is. But there's this fundamental confusion that seems to be tripping up a lot of innovators right now.
A kiss.
Well, the idea that ChatGPT is an AI agent, that's the critical misunderstanding.
Right. We all use these amazing tools, ChatGPT, Claude, Gemini. They're incredibly powerful large language models, LLM.
Exactly. Powerful, but they are fundamentally passive responders.
Yeah.
They're brilliant, sure, but static in a way. They wait for your prompt, they give a response, and, well, that's it. Their job's done.
They're trapped in a box, as the tech folks say.
That's the term, yeah. They can't act on their own in the real world.
And not grasping that difference, the gap between a passive language model and an autonomous agent, well, it's costing people productivity. It's causing them to miss out on what feels like the next really big shift in software.
Yep.
So, our mission today is pretty straightforward. We're going to dive deep into the source materials, give you a shortcut, really, to understanding this whole agent architecture. We need to unpack exactly what AI agents are, why an LLM like ChatGPT is, well, only the brain part, and what those other critical components are that let a system actually reason, plan, and crucially, execute actions on its own.
Okay, so let's draw that line right at the start. An AI agent, at its core, is a system. A system that uses a language model, yes, but its purpose is to achieve a user-defined goal, a comprehensive goal.
And the key word there is achieve.
Precisely. Agents don't just spit out text. They reason, they figure out the steps, they plan, and then they execute those actions in the real external world. That's the leap.
The flight booking analogy from the sources is perfect here. Let's walk through that.
Okay.
If you ask a passive LLM like ChatGPT, find me a business class seat to Tokyo next month under $3,000, what happens?
Well, it gives you a great response, probably very polite, detailing the steps you should take.
Right. First, check Skyscanner.
Second, compare prices on Delta and JAL.
Third, maybe look at different dates. It gives you instructions, a how-to guide.
Exactly. But now, ask a true AI agent that same thing. Find me a business class seat to Tokyo next month under $3,000.
What does the agent do differently?
It doesn't just tell you what to do, it does it. It autonomously searches multiple flight APIs. Maybe it knows your preference for certain airlines from past chats. It compares options. Finds deals. And here's the crucial bit. It actually reserves the seat, or at least gets to the point of asking you for final confirmation. It completes the transaction or gets right up to it, all within that single request.
So the goal isn't just understood, it's achieved, or nearly achieved.
That's the difference. Autonomy, goal completion.
And you mentioned this isn't magic, it comes down to structure. Every system that's truly agentic, meaning it can work towards a goal without constant hand-holding, relies on 4 core components working together.
That's right. 4 key pieces.
Let's start at the foundation then. Okay, component 1. Let's unpack the shift from just processing text to actually being an autonomous worker. The foundational piece is the language model, the brain.
Yep, the brain. This is where the reasoning happens, the decision-making engine. It provides that general intelligence, the ability to understand complex, nuanced instructions. And it generates the logic, the steps needed to solve the problem. But, and we have to keep stressing this, the LLM is not the whole agent.
Right. It's powerful, but it's operating in a kind of sandbox.
Exactly. It has no built-in way to get real-time info like today's weather, or browse a specific website, or query your company's internal customer database.
It only becomes an agent when
It's connected to tools.
Yeah.
And when it's wrapped in some kind of orchestration layer that manages the whole process.
Okay. So the first big decision for anyone building an agent is choosing the right brain. Because that choice impacts everything, right? Capabilities, complexity.
At cost. Definitely cost. The budget is a huge factor here.
So how do we choose? What are the categories?
We can pretty much break down the LLMs into 3 main camps, depending on what you need the agent to do, how complex the task is, how efficient it needs to be.
Okay.
First up, you've got your general-purpose workhorses. These are models like GPT-4o, Gemini 1.5 Flash, maybe DeepSeek's general models. They're the versatile middle ground.
Good all-rounders for the bulk of typical business tasks.
Exactly. They handle that, say, 80% of enterprise needs really well. They're reliable across different areas.
Like what kind of task? Give us an example.
Okay, imagine you're building a project management assistant. It needs to understand something fairly nuanced, like Summarize the key progress points from the last 2 weeks, but focus only on the project risks, and then draft a status update for Slack.
Right, that's not simple.
No. It requires understanding the nuance and coordinating multiple tools, maybe pulling data from Jira, checking Slack history, then formulating the message. These workhorse models can handle that mix of understanding and execution pretty reliably.
Okay, so that's the middle ground. What about simpler, maybe high-volume tasks?
That's where the small language models, or SLMs, come in. Think models like Google's Gemma, or maybe Mistral's smaller variants, or DeepSeek Coder R1 Distill.
And their advantages?
Speed and cost. They have fewer parameters, which means they run faster and are significantly cheaper for each token processed. Much cheaper.
So they're perfect when the task is well-defined, high volume, but maybe not super complex.
Precisely. Think about an agent whose only job is, say, categorizing incoming support tickets. Is it urgent billing issue or general inquiry, or maybe routing calls, or doing basic sentiment analysis on customer feedback?
It doesn't need to write an essay.
No. It just needs to classify input accurately and quickly. Using a big, expensive workhorse model for that is overkill. You'd be spending maybe 10 times more than you need to.
So you trade a bit of reasoning depth for massive efficiency gains.
Exactly. For those specific high-volume tasks, it's often the right trade-off.
Okay, workhorses, SLMs. What's the third category? The heavy hitters.
Right, these are the reasoning models. Models like the top-tier GPT-4 models, maybe Anthropic's Claude Opus, DeepSeek Coder R1. These are built specifically for really complex multi-step thinking.
What makes them different? How do they reason?
Crucially, they excel because they're designed to generate a long chain of thought internally before they give you an answer or decide on an action. They literally think through the problem step by step, considering different angles.
So if the workhorse is a skilled analyst.
The reasoning model is more like a tenured professor tackling a really tough research problem.
Okay. And where would you deploy these?
You use these for agents that need to solve, say, advanced math problems, or build complex financial models, or tackle really difficult coding challenges, or maybe even help with scientific discovery. Anywhere the intermediate logical steps are vital, and the agent needs to hold complex variables and relationships in its head, so to speak.
There's a catch, right?
Oh yeah, cost and speed. These models are significantly more expensive to run, sometimes exponentially so, compared to SLMs or even the workhorses, and they're slower.
So you only use them when the value of solving that extremely complex problem justifies the higher cost and latency.
Absolutely, it has to be worth it.
Okay, so we've picked our brain could be a nimble SLM, a versatile workhorse, or a deep thinking reasoning model. Now we need to give it the ability to actually do things, to interact with the world outside its text box.
Exactly.
Which brings us to component 2, the tools. The agent's hands and senses, you called them.
Yeah, this is where, for me, the magic really starts. Because tools are the bridge. They connect what the model knows internally with what it can do externally.
Interacting with other systems, APIs, databases.
All of that. Tools let the agent reach out and affect the world or gather information from it. And we generally see 3 main types of tools.
Let's break them down. First up, extensions. These are described as external APIs and wrappers.
Right. An extension basically connects the agent to anything outside your own application. Think weather services, flight booking systems like we mentioned, maybe Google Maps for directions, or even your company's payment processor API.
And how does the agent know how to use, say, a flight booking API?
It's fascinating. You, the developer, provide the agent with a formal description of that API endpoint, what it's called, what parameters it needs, like destination, date, number of passengers, what kind of data it expects back.
Like a technical manual for the API?
Pretty much. And then, based on the user's goal, book me that flight to Tokyo, the agent autonomously decides, okay, I need to use the booked flight extension. It figures out when to call it, how to call it, and what information it needs to gather from the user or its memory to fill in those parameters at runtime.
So if I say, what's the email address for user ID 123? And the agent has access to a get user profile user ID API extension.
The agent thinks, okay, goal is get email. The tool I need is get user profile. The required parameter is user ID, which is 123. And then boom, it makes the API call.
It translates natural language into a structured, executable API call.
Exactly. That's the power of extensions. Now, the second type of tool is functions, custom code.
And this is different, huh?
Functions are chunks of code that you, the developer, write and control completely, usually running on your own back-end server. This is often highlighted as the most powerful option and, critically, the most secure option, especially for businesses.
Okay, you brought up security. That seems important. If the agent is deciding when to call an API extension, what stops it from messing up, calling it too much, or sending bad data?
That's precisely the security advantage functions offer over external extensions. With a function, the actual code execution, all the security checks, the input validation, rate limiting, that all happens inside your application's controlled environment, often in a sandbox.
Not inside the agent or the LM itself.
Correct. The agent's job is just to decide which function to call and figure out the arguments or parameters it needs to pass. Your backend code then takes over, verifies everything, runs the logic securely, and sends back the result.
So the developer keeps total control. The function acts like a secure black box.
Exactly. Let's say you have some really complex proprietary business logic, like a function called calculate customer risk score,
Okay.
customer data.
Right, something you definitely don't want the LLM to see or replicate.
Absolutely. You expose that function as a tool to the agent. The agent learns when it's appropriate to call calculate customer risk score, perhaps when analyzing a new lead. But it never sees the internal code. It just provides the input data and gets the score back.
That maintains a crucial abstraction layer, protects your IP, prevents misuse.
Precisely. It's a very important pattern for enterprise agents.
Okay, extensions for external services, functions for secure custom code. What's the third tool type?
Data stores. This is all about giving the agent access to knowledge, current contextual knowledge.
Like its own library or knowledge warehouse.
Exactly. Connecting the agent to your existing data sources. These could be databases, SQL, NoSQL vector stores for similarity searches, maybe even just spreadsheets, PDFs, or your internal company wiki. Thousands of documents.
And how does the agent use this data? Isn't the LLM's knowledge frozen at its training time?
Yes, and that's the key problem this solves. This capability is fundamentally enabled by a technique called Retrieval Augmented Generation, or RAG.
RA. We hear that term a lot.
Yeah.
So RAG is the mechanism that gets around the LLM's outdated knowledge?
Absolutely. The LLM was trained, say, 6 months ago. It doesn't know what happened yesterday. Our RAG allows the agent, at the moment it needs the information, to reach into your connected data stores, retrieve relevant, up-to-date snippets of text or data, and then feed that current information into the LLM along with the user's query.
So the LLM uses that fresh data to generate its response.
Right. It augments the generation process with retrieved real-time information.
Let's use that customer service example again. Customer asks, "Where's my order?"
Okay. Without RAG, the LLM might just make up a plausible answer based on its old training data, which could be totally wrong.
But with R.
With RAG connected to the order database, a data store tool, the agent thinks, goal, find order status. It uses RAG to query the database for that specific order ID. It retrieves the current shipping status, out for delivery, delayed, whatever it is.
And then it provides that accurate real-time update to the customer.
Infinitely more useful. So these three tool types, extensions, functions, and data stores using RAG, are what really transform a static LLM into an active system that can interact with your whole tech stack and knowledge base.
Okay, so we've got the brain, the LLM, and the hands and senses, the tools. Now we need the parts that make the system truly smart, truly autonomous, the ability to learn, to remember, and to manage the whole process.
Exactly. This is where we get into the core of agency.
Let's start with memory, component 3. You said this separates the good agents from the great ones.
I really think it does. Memory allows the system to learn from past interactions, to maintain context over time, and ultimately to provide a much more personalized and efficient experience for the user.
Right, that amnesia analogy is useful. Without memory, every time you talk to the agent, it's like starting from scratch.
Total reset. You have to re-explain who you are, what you want, your preferences, the history of the task. It's incredibly inefficient.
So memory fixes that. But it's not just one simple thing, is it? You mentioned different types.
Correct. It's more nuanced than just looking back at the chat history. We typically talk about 3 key types of memory working together. First, there's short-term memory.
What does that cover?
This tracks the immediate context, the current conversation, the task right now, the last few things you and the agent said to each other. It ensures the agent understands the flow of the current interaction.
Okay, like the last few minutes of conversation. Then there's long-term memory.
Right. This is where the agent stores more persistent information across multiple sessions, maybe even over weeks or months.
Like what?
Things like your established user preferences. I prefer morning flights. My reporting format is X. It can also store successful strategies it used in the past to solve similar problems, answers to frequently asked questions it's learned, or key facts about your organization. This info sticks around.
Okay, short-term for the current chat, Long-term for persistent knowledge. What's the third type? Working memory. That sounds different.
It is, and it's a really critical distinction, often misunderstood. Working memory isn't just the chat history. That's short term. It's more like the agent's internal scratch pad or notepad that it uses while it's thinking.
While it's reasoning.
Exactly. When the agent is figuring out a complex multi-step plan or trying to solve a problem, it uses working memory to hold intermediate results, maybe different hypotheses it's considering, bits of conditional logic like, okay, step A led to result B, so now I need to check condition C before deciding on step D.
So it's temporary storage for the thought process itself.
Yes, temporary and task-specific. It pulls relevant stuff from long-term memory into working memory as needed for the current reasoning task, uses it to figure things out, and then might discard it once the task is done. It's vital for complex chains of thought.
That makes a lot more sense. The scheduling agent example really drives home the power of memory, particularly long-term.
It's a classic. You tell your scheduling agent once, maybe during onboarding, hey, just so you know, I never take meetings before 10 a.m. on Tuesdays.
Okay, just once.
That preference gets stored in long-term memory. Then, 3 months later, a colleague pings the agent asking to book a meeting with you on a Tuesday morning.
What happens?
The agent, during its reasoning process, pulls that preference from long-term memory into its working memory and thinks, user preference, no meetings before 10 a.m. Tuesdays. It then proactively avoids suggesting or booking any slots before 10 a.m.
Without me having to remind it?
Exactly. It remembers. That transforms it from just a tool into a genuinely intelligent, personalized assistant. That's the power of memory.
Okay, so that intelligence, that memory, it needs to be managed, right? Coordinated. That sounds like the job of component 4, the orchestration layer.
Precisely. This is the central nervous system, the glue holding everything together.
What does it actually do?
The orchestration layer manages the memory systems. It keeps track of the agent's current state, what it knows, what it's done, and most importantly, it controls how the agent reasons, plans, and executes its actions using the tools.
This is what makes the system truly agentic, autonomous.
Yes. It implements the core decision-making logic. And often this logic is built using specific mental frameworks or cognitive reasoning frameworks, as they're sometimes called. These guide the agent's thinking.
Okay, these frameworks sound critical. They're the engine of autonomy.
You could say that. They provide structured ways for the agent to tackle complex problems.
Let's get into them. The most common one seems to be chain of thought, or COTI.
CODA-T is foundational. It's a prompting technique, really, where you instruct the model to think step by step. You force it to break down a complex problem into a linear sequence of simpler thoughts before giving the final answer.
Like showing your work in math class.
Exactly like that. It makes the reasoning process more transparent, which is good for debugging, and it often increases accuracy because the model has a chance to catch its own errors by verifying each intermediate step.
So if I ask an agent to summarize 3 different articles and then combine the key findings.
Using COTI, the orchestration layer would likely guide the LM to first think. 1. Okay, let me summarize Article A, done. 2. No, let me summarize Article B, done. 3, now Article C, done. 4. Okay, now I will synthesize these 3 summaries.
A clear, linear process reduces the chance of just jumping to a conclusion.
Right. But sometimes problems aren't linear. Sometimes there are multiple possible paths forward or a lot of uncertainty.
That's where the next framework comes in. Tree of thoughts. TT.
Exactly. 2T is a significant step up from the linear COTI.
How does it work? A tree instead of a chain?
Pretty much. Instead of forcing the agent down a single reasoning path, 2T allows the model to explore multiple potential reasoning paths simultaneously, like exploring different branches of a tree.
How does that help?
The agent generates several possible next steps or thoughts. It then evaluates how promising each of these potential paths seems. It might pursue a few of the best ones for another step or two, and then it prunes or discards the paths that look like dead ends.
So it's exploring options before committing.
Yes. It's much better for tasks with high uncertainty, like creative writing, complex strategic planning, or situations where you need to find the best solution among many possibilities, not just a solution.
It's like the agent running mini simulations or hypothetical.
That's a good way to think about it. More sophisticated, but also more computationally intensive than COTI.
Okay, COTI for linear problems, 2T for branching possibilities. But you mentioned the ultimate engine of autonomy, the core loop for interacting with the world, REACT.
Yes, REACT stands for reason and act. This is arguably the most fundamental framework for building agents that do things using tools.
Let's really break down this React loop. That sounds crucial.
It is. It's a dynamic, iterative cycle. It basically works in 3 repeating steps.
Okay, step 1.
Reason. The agent first looks at the current situation, compares it to the overall goal, and reasons about what single action it should take next to get closer to that goal. This reasoning step often involves pulling info from memory, maybe using COT or even TOT internally.
So it thinks about what to do, then.
Act. Based on its reasoning, the agent chooses a specific tool to use, maybe call an API extension, execute a custom function, or query a data store via RAG, and then it acts by making that tool call.
It does something. And the third step.
Observe. The agent receives the result, the output from the tool it just called. This is the observation. This observation changes the agent's understanding of the world state. For example, it now has a new piece of data, or it knows a booking was confirmed.
And then the loop repeats.
Exactly. The agent takes this new observation, feeds it back into the reason step. It thinks again. Okay, based on what just happened, what's the next best action? And it goes through reason, act, observe again and again and again.
Until the original goal is fully achieved.
Precisely. It's a continuous cycle of thinking, doing, and learning from the result.
Let's use that troubleshooting example to make it concrete. Task. Troubleshoot why the database connection failed last night.
Okay, perfect.
So, first loop.
Reason. Agent thinks, goal is root cause of DB failure. First step. I need the system logs from last night. Act. It calls the fetch system logs, date yesterday, function tool. Observe. The function returns, say, 500 lines of log data. The agent processes this observation.
Okay, loop 2.
Reason. Agent scans the logs and sees a specific error message. Disk full error at 02.15 a.m. It reasons, okay, the logs point to storage saturation, hypothesis, the disk filled up. Next action, I must verify the current disk usage on the database server. Act. It calls an extension tool, maybe check disk usage. Observe, tool returns disk usage, 98% full.
Got it. Loop 3.
Reason. Agent thinks, observation confirms hypothesis. Disk is full. Root cause identified. Next action. I need to report this finding and suggest a solution, like clearing old log files. Act. It might call another function to generate a formatted report or send an alert. Observe. It gets confirmation the report was sent. Maybe the goal is now achieved.
That React loop is clearly the difference between a tool that just tells you how to troubleshoot.
And an agent that actually does the troubleshooting for you, step by step, reacting to what it finds along the way. That's real agency in action.
Okay, this is making a lot more sense. Once you have those 4 components dialed in, the right LLM brain, the necessary tools, effective memory, and a robust orchestration layer using something like React, you've got the building blocks for a single, powerful, autonomous agent.
Right, a single agent system, one LLM, maybe with a set of tools, executing a workflow. That's very effective for many tasks that are well-defined and can be handled by one mind, so to speak.
But the real paradigm shift you suggested happens when these agents start collaborating.
Exactly. For really big, complex, enterprise-scale problems, you often need more than one agent. You need coordination. You need multi-agent systems.
Like building a team of specialists.
That's the perfect analogy. You structure the system like a high-functioning team where the overall complex workflow is broken down and distributed across multiple coordinated agents. Each agent might have its own specialized LLM, its own unique set of tools, maybe even its own memory focused on its area of expertise.
Interesting. So how do you structure these teams? Are there common patterns?
Yeah, we're seeing a couple of main architectural patterns emerge. The first one is pretty intuitive, the manager pattern.
Like a boss and employees.
Pretty much. You have a central manager agent. It receives the initial high-level complex goal from the user. Its first job is to reason about that goal, break it down into smaller, more manageable subtasks.
Okay, it does the planning.
Right, and then it delegates each specific subtask to a specialized worker agent that's best suited for that job.
Give me an example.
Let's say the overall goal is launch a new multi-channel marketing campaign for product X. The manager agent might break this down and delegate. Task 1. Write compelling ad copy for social media. It delegates this to a specialized copywriting agent. Task 2. Analyze target market segments based on recent sales data. Delegates to a data analysis agent with access to the sales DB. Task 3. Forecast the budget required for the proposed channels. Delegates to a financial planning agent.
And the manager agent's role is then to coordinate these workers.
Exactly. It collects the results back from the worker agents, maybe asks for revisions, and synthesizes everything into the final campaign plan. It handles the high-level strategy and coordination.
That makes sense. Are there downsides to the manager pattern?
It can sometimes introduce bottlenecks or latency. Every piece of communication often has to flow back through the central manager, which can slow things down, especially if the manager gets overloaded.
Okay, so what's the alternative?
The decentralized pattern. Think of this more like a peer-to-peer network or a flat organizational structure.
No single boss.
Right. In this model, agents hand off tasks directly to each other as peers, based on who has the next required skill or piece of information. There isn't one central agent overseeing every single step.
How do they know who to pass the task to?
That's where it gets more complex. It usually relies on predefined workflows or protocols. Agent A knows that once it finishes its part, the output needs to go directly to Agent C for the next step, maybe bypassing Agent B entirely for this specific task.
So it could be faster, more efficient.
Potentially, yes, especially for workflows that involve lots of rapid handoffs between specialized systems. It's often more scalable, too.
But the coordination seems harder to manage.
It requires much tighter design and control over the communication protocols between the agents to make sure things don't get chaotic or dropped. You need very clear rules of engagement.
Okay, so whether it's a managed team or a decentralized network, these agents need to talk to each other. And they need to talk to the outside world, their tools. If they're built by different companies using different models,
Yeah.
how does that work?
That's the million-dollar question right now. They can't just rely on custom proprietary connections for everything. It wouldn't scale. It would be chaos.
We need standards.
Exactly. We desperately need universal ways for agents to communicate with external tools and, just as importantly, with each other. This is where agentic protocols come in, standardizing the communication.
And the big tech companies are working hard on this.
Massively. Think about it. How does an agent built using Google's tools reliably and securely use an external financial data API that follows a certain standard? How does that same agent then securely pass a task to another agent built using, say, Anthropic's models running on a completely different cloud? We need common languages, common interfaces.
Our sources pointed to two major protocols leading the way here. Let's start with the Model Context Protocol, or MCP, from Anthropic.
Right. MCP is focused on standardizing how external applications provide context to LLMs, and critically, how those LLMs connect to and interact with external tools and services.
So it's standardizing the plugs for the tools.
That's a great analogy. Think of it like USB ports or standard power outlets. If every tool, every API, every data source adheres to the MCP standard for how it presents itself and exchanges data, then the agent doesn't need a unique custom adapter or driver for every single tool it wants to use.
It simplifies integration massively.
Hugely. So going back to your example, an AI agent running inside Slack could potentially use MCP to interact directly with an Asana API to pull the latest project updates. Asana just needs to expose its data via the MCP standard.
And the agent knows how to plug into it without needing custom code just for Asana.
Exactly. MCP standardizes that agent-to-tool interface, but that's only half the puzzle.
Right, because agents also need to talk to other agents.
Precisely. And that's the focus of the second major protocol mentioned, the agent-to-agent protocol, or A2A, which Google is championing.
A2A. This sounds like the key to enabling those multi-agent systems, especially the decentralized ones.
It absolutely is. If MCP standardizes the power outlets connecting agents to tools, A2A aims to standardize the intercom system, or the secure memo format used for communication between the agents themselves.
So one agent can reliably send instructions, data, or requests to another agent, even if they're built differently or running elsewhere.
That's the goal. A2A is designed to enable robust, secure, and meaningful communication and collaboration between different AI agents directly, even across different servers, different cloud providers, different underlying frameworks.
Okay, let's try to connect these two protocols using that Slack Asana example again.
Good idea.
So the Slack agent uses MCP to talk to the Asana tool, pulls the project updates.
Okay.
And in processing those updates, the Slack agent identifies a critical software bug has been reported in Asana. Now, writing a detailed technical bug report isn't the Slack agent's main job. It needs help.
Right. It needs to delegate that specialized task.
So instead of trying to write the complex report itself, it uses the A2A protocol
to securely communicate with a separate, specialized technical reporting agent. This agent might be an expert system specifically trained for bug analysis and reporting, maybe running on a completely different server farm.
And the A2A protocol allows the Slack agent to securely send all the relevant context, like the bug description from Asana, maybe related logs it found.
Exactly. It packages up the task and the necessary data using the A2A standard and sends it off. The specialized reporting agent receives it, does its expert analysis, generates the properly formatted, detailed bug report.
And then uses A2A again to send the completed report back to the original Slack agent.
Precisely. Which the Slack agent can then present to the user or file in the appropriate system.
Wow. Okay, so the protocols are totally complementary then. MCP connects agents outward to their tools and data sources. A2A connects agents horizontally to each other for collaboration and delegation.
You nailed it. Together, they lay the foundation for a truly interconnected ecosystem of autonomous agents, capable of tackling incredibly complex tasks by working together as a distributed, intelligent team. Okay, so we've covered a lot of ground. We know what agents are, the components they need: brain, tools, memory, orchestration, how they think using frameworks like React, and how they can communicate using protocols like MCP and A2A.
Right. The big question now, for you listening, is the practical side. How do you actually start? How do you go from just using ChatGPT to actually building or deploying your first agent?
Yeah, let's get practical. Based on the sources and what we're seeing, there seem to be about 4 main paths forward. Which one you choose really depends on your current technical skills and what you're trying to achieve.
Okay, path one. This sounds like the easiest entry point. 1 prompt agents.
This is definitely the starting line, lowest barrier to entry. Here, you're not really coding an agent in the traditional sense. You're achieving a basic level of agency by crafting a single, really well-designed, complex prompt.
A super prompt.
Kind of. You create a very detailed system prompt that essentially guides the LLM's internal reasoning process. You might include instructions that mimic a React loop, like telling it explicitly. Think step by step about the problem, identify the information you need, formulate a plan, then provide the answer.
So the agency comes entirely from clever prompt engineering.
Pretty much. It works surprisingly well for relatively straightforward self-contained tasks. Things like generating a detailed competitive analysis report based on provided text, or answering complex FAQs by reasoning through internal knowledge, or maybe doing multi-step data synthesis from a document.
What skills do you need?
Mostly just strong prompt engineering skills, understanding how to structure prompts to elicit complex behavior from the LLM. No actual coding is required.
Are there specific tools for this?
Yeah. Often the tools are just advanced interfaces built on top of standard LLMs that make it easier to craft and manage these complex prompts. The sources mention things like Manus Operator, or maybe even how people use Perplexity for research, guiding the model through steps via the prompt. It's a great way to get your feet wet and start thinking in an agentic way.
Okay, that's the entry point. What if you need to automate more serious business processes, but you're still not a hardcore coder?
That brings us to path 2, workflow-based agents. Think automation platforms.
Like Zapier or Make, but maybe more AI-centric.
Exactly. These platforms provide visual, often drag-and-drop interfaces for building quite complex workflows. You can chain together LLM calls with pre-built connectors to common business tools like CRMs, email, databases, Slack, etc.
So they handle the tricky parts for you.
To a large extent, yes. They manage the orchestration layer, the state management, often provide basic memory capabilities, and handle the integration with many common tools through built-in functions or extensions.
This sounds like it really democratizes agent building for business users or citizen developers.
Absolutely. It's perfect for automating those multi-step business processes. For example, setting up a workflow that monitors an inbox for customer support emails, uses an LLM to understand the intent and urgency, automatically creates a ticket in Jira or Zendesk, maybe retrieves customer history from a database, and then drafts an initial reply for a human agent to review.
All visually configured.
Mostly, yes. Tools mentioned in this phase include things like N8N, Make, which you mentioned, Diffie, maybe Langform. They give you significant agent power without requiring deep Python or JavaScript knowledge.
Okay, paths 1 and 2 are low code or no code. Path 3 seems aimed squarely at developers. Coding agents.
Right. These are interesting because they are AI agents designed specifically to help humans write code faster and better. They aren't typically solving end-user business problems directly. They are agents that assist in the process of software development.
So an AI pair programmer.
Essentially, yes. They integrate directly into your coding environment, like VS Code or specific cloud IDEs.
What can they actually do for a developer?
A lot, actually. They can help debug complex code by analyzing huge code bases much faster than a human. They can automate repetitive tasks, like writing boilerplate code or generating unit tests based on your existing functions. And perhaps most famously, they provide intelligent code completions, suggesting not just the next line, but whole blocks of code that fit the context and your project's architecture.
Tools like GitHub Copilot are probably the best known example here.
Copilot is a huge one, yes. Others mentioned include Devin, Replic's AI features, maybe tools like Cursor or Cody from SourceGraph. The difficulty level varies depending on how deeply you integrate them, but they fundamentally use LLMs trained extensively on code to boost developer productivity.
Making the builders themselves more efficient.
Exactly.
All right, that leaves path 4. This sounds like the most powerful, most flexible, but also most complex option, agentic frameworks.
This is the professional developer's toolkit for building serious, custom, production-ready AI agents. Frameworks like LangChain, especially its LangGraph component, Llama Index, maybe Microsoft's Semantic Kernel, Google's new Agent SDK, or frameworks focused on evaluation like TrueRes, Trulens, provide the underlying structures, reusable patterns, monitoring tools, and best practices needed to build sophisticated agents from the ground up.
So this is when you need maximum control and customization.
Yes. You use these frameworks when a visual builder, Path 2, isn't flexible enough, or when you need to implement highly specific proprietary business logic within the agent's reasoning loop, or if you're building complex multi-agent systems that require non-standard communication protocols or very fine-grained control over memory and tool use.
Or maybe for cutting-edge research and development.
Definitely. If you're pushing the boundaries of what agents can do, inventing novel architectures, or need extremely robust security and observability for a high-stakes application like, say, real-time financial trading agents or complex scientific simulation agents, you'll almost certainly be using one of these frameworks.
What's the difficulty level here?
Medium to hard, generally. You need solid programming skills, usually Python, and a good grasp of the agent concepts we've discussed: LLMs, tools, memory, orchestration patterns like React. But for building truly custom, scalable, and defensible agentic applications, investing the time to learn a framework is often necessary.
Okay, so let's summarize the advice. Where should someone start?
Start simple. Play around with one-prompt agents, Path 1, just to get a feel for guiding an LLM's behavior. Use tools like Perplexity or Crash Complex Prompts in ChatGPT or Claude.
Then, if your main goal is automating business processes without diving deep into code.
Then workflow-based agents, Path 2, using platforms like N8N or Make, are probably your best bet. They offer a great balance of power and ease of use for many common tasks.
If you're a developer looking to speed up your own work,
Explore the coding agents, Path 3, like Copilot or Cursor. They can be a massive productivity boost.
and finally, if you need to build something truly custom, powerful, and production grade,
Then you need to roll up your sleeves and learn an agentic framework, Path 4, like LangGraph or Llama Index. The control and flexibility they offer are essential for those cutting-edge applications.
that's a really clear breakdown of the paths forward.
Hopefully it helps people figure out where to jump in.
Absolutely. So just to quickly recap for everyone listening, you should now have a solid grasp of the 4 core components that power every AI agent. The language model, the brain, chosen based on the task, the tools, the hands and senses, including secure functions and knowledge-giving RAG, memory, the context keeper with short-term, long-term, and that crucial working memory, and the orchestration layer, the nervous system using frameworks like POTI, TTT, and especially React to manage the whole process.
And crucially, you understand that fundamental difference. A passive LLM responds, while an autonomous AI agent acts to achieve a goal.
Plus, we touched on the protocols MCP for standardizing tool connections, A2A for enabling agent-to-agent collaboration that are paving the way for these agents to work together in sophisticated, distributed teams.
Which leads us to a final, pretty provocative thought, something for you to maybe mull over after this deep dive.
Okay, leave us with something to think about.
Well, if these multi-agent systems, especially the decentralized ones, start using standardized protocols like A2A to securely delegate complex, even critical business tasks to other specialized agents that might be running on completely different servers, maybe even owned by different vendors, if they can act together autonomously, like a distributed, highly specialized digital workforce. What does that really mean for the future architecture of enterprise software itself?
You mean instead of buying one giant monolithic software package?
Could the application of the future actually be an emergent team of collaborating autonomous agents? A flexible swarm that dynamically manages critical internal functions, finance, HR, supply chain, customer service, by negotiating tasks and executing goals among themselves using these standard protocols.
Wow, so the software is the team of agents.
Potentially. The implications for how we build, deploy, manage, and secure enterprise systems are, well, they're massive. Think about vendor lock-in, data security, resilience, even organizational structure. It suggests a pretty radical shift away from fixed code towards these adaptable, decentralized AI teams running core operations.
That is definitely something to chew on, a future managed by collaborating AI teams.
Something to consider.
Okay, well, on that forward-looking note, thank you for that incredibly insightful breakdown. For everyone listening, the call to action is clear. Pick one workflow, maybe something simple you do regularly. Think about those 4 paths we discussed: prompt engineering, visual workflows, coding assistants, or frameworks, and try to build your very first simple agent this week, even if it's just a complex prompt. Dip your toes in.
Exactly, because the future of autonomous work, driven by these agents, it's not just coming, it's already starting to arrive.
Yeah.
And your ability to understand and leverage them is going to be crucial.